I came up with another problem here. These pieces here have to do with a bell crank that's in the brake system. This goes over to the brake pedal, and then this push rod goes back to this bell crank, which is mounted on the side of the frame. My problem was I found this piece, which is here, the bell crank, because I had it chrome plated, but I couldn't come up with this stud here. They call it a bearing bolt is what they call it in the parts manual if you look it up. So I spent about 30 minutes looking for it, but I finally found it in a box in the bottom of a box of parts. Like I said, I threw all the stuff in there and I should have been more careful, but I'm sure it's the right thing because here it is, and you can see it has little traces of blue paint on it. And I thought I'd show you this mostly because I'm proud I finally found it, but this is an example of just how well made these Sears bikes were. This has a grease hole in it right here that was drilled in, and of course they bored in the end here to go in there so they could put a grease fitting on there. So this bell crank was made to be greased over the years as it's working back and forth on here. So it's not something you'd see very commonly on most bikes. This grease fitting, I think probably I didn't have it where it should have been, was because I want to take this grease fitting out and change it for a US type Zerk fitting, because maybe people be more apt to grease it, but chances are nobody will. Nobody ever greased this one since 1955, I'm sure. So I'll work at cleaning this up. I like to try to test things before I put them on the bike. So one of the things I tested was this headlight bulb, and I found out one filament is burned out. So I don't know whether it's the low beam or the high beam, but one filament was burned out. I test them with the 6-volt battery charger there, and I can see how many amps it pulls with that. This horn was the next thing I tested, and I find out it doesn't work at all either. It's quite a heavy horn. I bet that thing weighs 2 or 3 pounds. And I'm going to have to take it apart to see if I can fix it. It looks like one that came off a Volkswagen Beetle or something, but that's what was on there, and I'm sure that's the right horn because, again, it had traces of that metallic blue paint on there, which I've been working on trying to get off. But I'm going to see if I can repair that horn. Now, what I've done about the horn is I've taken these little screws out and removed this retaining ring off there that holds this diaphragm on there. This is a metal diaphragm that's supposed to vibrate back and forth. It's made out of some pretty heavy stuff. And actually I see it has a piece of metal here to buzz, and then you got another one on there that make it probably even louder. So these little laminations right here are attracted to this magnet right here, and I suppose you can see here there's some kind of, it's real sticky, kind of dried up grease on there. And anyways, that's what this coil of wire that's in here is going to magnetize these laminations and pull this diaphragm down to them when you turn on the current. And then when that pulls down, it's going to, once it gets all the way down, it breaks the current on. You can see there's little contact points. They're right in there. And when the contact points open, that shuts off the current. So it's turning itself on and off, on and off, on and off, and it's just buzzing like a doorbell buzzer or something. But when you put a big diaphragm on there, instead of going like a buzzer, it's going to go beep like a horn, and be a lot louder too with the big metal diaphragm. So all I have to do, I see the coil's good. I've tested that with my battery charger, and I think all I got to do is clean it up and get these contacts clean, and then I should be able to fix it and get it working again. I sprayed out this grease that's on here. I should tell you that. I sprayed out the grease that's on here. Used carburetor cleaner down in that hole because it was all full of grease down in there. So got that cleaned out. Now what I've done is taken this thing apart, and in here where there's contacts right in there, they look like ignition points or something. You see this little metal, I guess it's made out of metal. I don't know if it's metal or, I guess it's a phenolic maybe, but it's where one of the contacts are on there. And when this plate's in there, it has to, when it comes down hard against this magnet, that plate is going to hit this piece of phenolic and break the contact in those points. So that'll shut it off. So when you put the power on right now, it's going to turn this into a magnet. When you push on that thing, when the plate comes down and puts it, it kind of turns itself off. Well, once it's off, then it's going to allow this metal plate to spring back up. And when it springs up, then it makes contact with this point and turns itself back on. So it just goes back and forth like that. And that's how the horn works. It's not that complicated, but this one's pretty complicated because you gotta make sure that this metal plate that's hopping up and down doesn't rotate this way or that way. It has to be so it's going to hit this little tiny piece of phenolic sticking out here, and that's not too much to hit, but that's it right there. Now there's a lot of adjustments here. There's adjustments here. You can tighten this thing, which has to do with this spring here, and the main thing is to get the magnet turning on and off at a frequency that makes a tone that you like it to be, and you can adjust that. Now one of the ways they adjust it, if you look back in here, you see there's a spring back in there, and that spring, there's almost always on a horn there's a screw, and by turning that screw right and left, you can get the pitch higher or lower, louder or softer, you know, just by moving that back and forth until you get it to sound the way you want. And that's what that screw does. But if you go too far with it, it's going to put so much pressure on this piece of metal here that it may be that the points won't open, or if you don't have enough pressure, they won't close. So everything's a balance there, but that's the way it works. But I'm just fooling with it with the battery charger here to see if I can't fix it. It's buzzing like a buzzer now. It's not going to be very loud because it's not mounted correctly, but this here adjustment screw, if I turn that's about the loudest right there. Except when it starts, it doesn't want to start. Oh, 12 volts, that'll really do it. I think probably I don't have enough amperage here to really honk it right. Well, I'd say that's about the strongest vibration I get is right set right like that, so I'm going to leave it there. I have to make it honk and sound right. You have to have these metal pieces on there, so a little bit of spring to it. That's 6 volts, but you can see it's taking a lot more amps than the little 6 amps that this thing can put out. You can see the dial going way up. If I try 12 volts, it pulls about 4 amps there, but it's plenty loud enough. So if I fool around with this adjustment screw back here, but it's only pulling 2 amps there, so 6 volts to 2 amps, that's a little better. So I just fooled around watching these amps and adjusting this screw back here until I got the sound where it looks like it's going to honk every time. But I don't think it's ever going to sound right with a battery charger on it. You need a battery that's got a lot more amps, because on 12 volts, that's pretty loud. What I had to watch out for was getting these little spacers. They look like a washer, but they've got a little flange turned on them right here. They look like a washer, but they got a flange turned on them, and you got to get those in there right. So you have 3 pieces of this vibrating spring steel here. The other thing was, when you take apart the diaphragms in here, if you take these screws out and you take the diaphragms off, you got to watch real careful the spacing of different washers. One of the washers has a pin in it so that nothing can rotate, and that all has to go down in there. The diaphragm and the shaft and the assembly for the diaphragm has to go down in there, positioned so that the magnetic, I suppose you'd call it an armature, is able to hit those contacts to push that little piece of phenolic up and down to break the contacts when the horns goes off, so it turns on and off like it's supposed to. And you have to get all that on there so that it's square with when the pin goes in the hole through the diaphragm. You have to get these screws here positioned right so that the armature is going to be able to hit those contact points. But that's the only part I'd say it's kind of tricky to put together, is that you got to get all that stacked up in there right. And this in here, I suppose you could tune this to get maybe a different sound out of it by loosening this nut. There's a washer in there that's kind of a concave spring washer like, but you could probably tighten this nut or loosen it to put more pressure or less, because there's actually 2 diaphragms. This thing you're looking at here is the second diaphragm. There's another metal diaphragm that goes under these screws here back there, a big diaphragm there. This one's a little smaller and it just moves back and forth. So what the purpose of that is, I don't know. Maybe it makes it louder. Also, I'd like to make sure that this drain hole here is up and this drain hole here is down, so that water would drain out of there if any got in. Now this thing mounts in the toolbox, so it's kind of hidden from view. People can't really see it. These wires that are on it really aren't heavy enough wires, but I got it so it only pulls 2 amps on 6 volts. So I think that's pretty good. Of course, it's quite a bit louder on 12 volts, but I think if it has the right size wires on here and ran off a battery instead of a battery charger, it would probably be pretty good, fit to run anyway. So that's how I fixed the horn.